Good morning to all. And now I am going to talk about my project title is IOT Based Monitoring System for High Level Ammonia Detection in Poultry Farm. This project is done by the under the guidance of the Mrs. M. Kavita Madam. These are my project teammates Aditya Murthy, Akash, Ariram. So we will discuss about the introduction of this project. So poultry farm plays a vital role in food production, egg production, maintaining the safe environment and daily life. We expecting the food production. So here one of the most dangerous problems are required. Right, harmful the body health, reduces the productivity, affect the workers. Ammonia gas is the vital role plays a dangerous of our human life. So we can reduce the ammonia gas target of this project using this compounds. We will see the next topic, low cost solutions. Next topic is problem definition of this project. What are the problems are required in this? See, poultry farm generate the high level ammonia gas from waste decomposition. It has affect the skin, eyes, respiratory issues, health life, and mainly downfall the downing the egg production, poultry production. It will excess the economic problem mainly, and time consuming income graded lack of real responses occurring say loss of poor farm maintenance. It totally affect our human life and economic rights. These are the problems. Next we see the methodology overview to overcome that problems. The sensing stage, the MQ137 ammonia gas sensors are continuously monitoring the ammonia concentration, and DHD level sensor reduce records the temperature, humidity. So how we maintain the correct and temperature to overcome signal processing ESP microcontroller reads a sensor value sensing that decomposition of this project. The decision making, if ammonia exceeds means threshold, trigger the warming actuator safe continuous monitoring of this alert to the mobile recovery. Next, the actuators and alerts. The exhaust fan pump ventilation activates a readily module notification alert sensor to users. We can alert to reduce this project. Finally, we see the system block diagram. ESP32 CAM microcontroller. This and exhaust fan channel relay pump. These are connected to the microcontroller and micro MQ137 DST level. Finally, we connected to the Wi-Fi module or mobile PC. We can watch through the CAM module. What are the problems occurred? Alert systems we mainly used in this project. Next topic can continue to by the Aditya Murthy. Thank you.
Workflow of purpose system start utilizing the ESP32 CAM MQ137 DTH11 relay read ammonia temperature humidity values, process the sensor data, compare with the threshold effects, literature review, author here Suresh, title is monitoring and control ammonia gas poultry farm using IoT methodology. Used ESP8266 MQ137 sensor alerting that trigger manual fan activation. Kumar 2020 Smart Poultry Farm using IoT and cloud computing. Employee node MCQ ESP8266 MQ137 Think Speak for real-time gas environmental monitoring system. We are using the tools and softwares. Arduino IDE programming upload and code for ESP32. ESP board package support ESP32 CAM development. Arduino C++ microprogram. Proteus software to use the simulation visual circuit designing test. Blinked IoT platform real-time monitoring alert. IoT dashboard debugging the data visualization. M MS PowerPoint, MS Word, project report and PowerPoint presentation. Thank you.
Next slide is about the technical working of our project. It is very simple. The MQ137 sensor detects ammonia gas and the DHT11 sensor measures temperature and humidity. These values are processed by the ESP32 CAM. The ammonia level crosses the safe limit. The relay turns on the exhaust fan and the pump motor automatically. This helps to improve air quality inside the poultry farm. And next is the proposed solution. It is to overcome ammonia gas problems in poultry farms. We implemented an automatic monitoring and control system. If the gas level becomes high, the system automatically turns the pump motor through the relay. That helps in maintaining safer and healthier poultry farm environment. The next slide will continue by Akash.
Topic is future work. Rubst housing for sensor. Design weatherproof and dustproof. Enclosed for a sensor to improve the durability and harsh poultry environments. Data analytic dashboard. Poultry farms with a web-based dashboard showing graphs, trends and improved decision making. For productivity, multiple gas detection. Extend the distant system to detect harmful gases, CO2, methane, and hydrogen sulfide. AI based prediction. Implement machine learning algorithms to predict ammonia level to alert the system. Scalability and networking. Develop support for monitoring with multiple poultry farms in a single hub. Next is reference. Yes, Suresh, monitoring and controlling for ammonia gas in poultry farm using IoT. Yeah, I mean IoT based real time air quality monitoring system using ESP32. N Kumar, smart poultry farm using IoT and cloud computing. MQ137-8, Vincent Electronics. Next is conclusion. The proposed IoT based ammonia monitoring system provides a smart solution for poultry farms. The integrated sensor with the ESP32 cam, it enables to real-time detection for the ammonia gas, temperature and humidity. The approach reduces manual effort, economic loss and environment risk. Overall, the project demonstrates an effective, low-cost and scalable solution for maintaining healthier poultry environment.